For this example, let's consider the function f of x is equal to cosecant squared of x. So here's its graph, and if we're near pi, it looks like there is a vertical asymptote in the graph. In fact, in terms of limits, the limit as x approaches pi of cosecant squared of x is equal to positive infinity. Now we're just figuring that out by using the graph, but I'd like to talk about the precise definition of a limit if your limit is becoming infinite. Here is how it will work. What we do is we choose a number over here. I'll start with 50. And you can ask the question, 50 intersects the graph in these two places. And you can notice that here and here, cosecant squared is always above 50 because it's tending towards positive infinity. So I get these two intersection points. Now on the x-axis, this spot corresponds to a place down here, and this one corresponds to a place down here. That means there is an interval around pi where every single x value that falls within this interval goes to a y value that's bigger than 50. Now, there's nothing special about 50. I could have said the same thing about 100. At 100, it intersects the graph in two places. It corresponds to two numbers down here that are around pi. It's more narrow, but everything in that interval, those x values get mapped to something that's greater than 100. And then you just repeat this process forever. Again, nothing special about 100. I could have said the same thing about 1,000, 10,000, a million, a billion. If you can do this process forever, that's our way of saying precisely that the limit is going to be infinite. So again, that idea is you choose some value over here. You can call that some number m. It'll intersect the graph in a couple of places. And then our job is to hopefully find an interval down here where all the x values, when you map them into the function, give you y values that are bigger than this value m that we're choosing. So I'll write that down precisely over here. This is the precise definition of something going to infinity. For all, I'll say capital M greater than 0. That means you first choose your number on the y-axis. There is a delta greater than 0, so that 0 less than the absolute value of x minus pi less than delta implies that the function f of x is bigger than or equal to m. So to go through this, you choose any number over here. You then want to find an interval down here. That means you're finding a delta such that this happens. And every x that you choose in this interval will give you a y value that's bigger than the value m that we chose. So here m can be, again, like a billion, a trillion, and so on. It can be very, very large. And that never ends, meaning the limit becomes infinite. So let's try to use this idea here in example 1. Again, I have the graph of cosecant squared of x from the previous slide. And here's what I want to do. I want to find a number delta so that if 0 is less than the absolute value of x minus pi is less than delta, this will imply that the function cosecant squared of x is greater than 100. And we're going to round our answers, it says, down to 3 decimal places. So here's what this question is saying. It's saying, look at the y values of your graph and locate 100. So that is here. I look over and I see, okay, well, that meets the graph here and here. These 2 points correspond to x values down here on the x-axis. So some spot here and some spot here. Any x that we choose in here, when we map it into the function, is going to give you a y value that's greater than 100. So our goal is, well, what is that delta? How far to the right and how far to the left can you go? So to answer this question, here's what we need to figure out. When is cosecant squared of x equal to 100? So that's when this line intersects the graph of cosecant squared. If you can solve this for x, it'll give you values down here that you can use to determine delta. Okay, so step 1, let's actually solve this equation. I think a good first step would be to take the square root of both sides. So you can take the square root of this side and the square root of that side. And this changes the equation to cosecant of just x is equal to, well, it's really plus or minus 10. And the fact that we have two solutions here is a great thing because, well, there's two solutions over here. I see there's some metric about pi, so I'm going to focus on just the positive solution. Finding delta means you just have to find the distance from the center out to one of the sides, so I'm only going to choose one of the solutions. So where is cosecant of x equal to 10? Now the definition of cosecant is 1 over sine of x. And we're asking, where is that equal to 10? You can cross multiply and write this as 1 over 10 is equal to sine of x. Now there is no nice solution to this equation. I think we have to use an inverse trig function to figure out the value for x. So that is, we're going to apply sine inverse to both sides of this equation. So on the left, we have sine inverse of a tenth. On the other side, we're going to have sine inverse of sine of x, like this. So here we applied it to the left, and we applied it to the right. On the right, sine inverse of sine, the fact that they're inverses means they cancel and it gives you just x. And then sine inverse of 0.1, or a tenth, is a number that you can get from a calculator. Now, one thing to be careful about is when you use the sine inverse function to solve for x, the way it's defined is it'll only give you a value between negative pi over 2 and pi over 2. So we'll have to use that information to reason out, well, it's going to give me an answer somewhere over here. How can I use that to figure out what's going on over here? So I'm going to type this into my calculator, and I'm going to make sure that it is in radian mode. So sine inverse of a tenth is, okay, I get x is 0.100, and I'll go 17. I'll round to here. So this number x is right about here. It's just a little bit over. And if we solve the negative solution, it would mean you'd go a little bit over to the left this way. How does that help us figure out these values over here? Well, you're going a little bit over that 0.1 over here and 0.1 over here. So even though it gave us these solutions, I know that it's really telling me the distance I'm going from pi in this direction to pi in this direction. So the question is, what value of delta do I want to use? Well, the distance from here to here, if we round down to 3 decimal places, it's 0.100. So delta is equal to 0.100. That is the distance that you want to go in both directions around pi, so that whatever x value you choose in here is going to take you to a y value that is above 100. The last thing to point out is that we rounded down. And if you round down, it makes your interval smaller. And making the interval smaller is a good thing. If you expand the interval, you might actually end up with values that aren't above 100 in this case. But rounding down means, okay, that's going to make it smaller, so all the x values within here are going to work. This process will work for any number. I chose 100, but you could put any number here, and the process would be exactly the same.